All right, so this is a function. Why is this a function? Passes the vertical line test. No matter where you draw that vertical line, we talked about that last class period. No matter where you draw that vertical line, it intersects it once. Now remember, that means that if you look at this vertical line, that for this x value right here, there's only how many y values? One. And that's true no matter where you are. So it passes the vertical line test as a function. But all of these are relations, and you can find domain and range of a relation. Doesn't have to be a function. In this case right here, how do we find the, let's do the range first. How do you find the range?
Up and down. Wait, no, range is what?
The range is a set of y coordinates. You got to use the mathematical terminology. The range is a set of y coordinates, and when I'm finding the range, when the graph is given, you're going to go along the y-axis. And remember, whether it's interval notation or inequality notation, you're going to go from smallest to largest. So I'm going to go from the lower part of the y-axis to the upper part. So when I move along the y-axis, and if you need to bring a straw on test one, bring a straw on test one. So when I go along the y-axis, where do I start touching the graph? Right here. What is that y value? -3. And I'm going, do I stop anywhere? Do I keep on going? Keep going. So what's the range as an interval? Bracket, -3, infinity with parentheses. We talked about the fact that parentheses, with the infinity, -infinity, you're always going to use parentheses. As an inequality, because on my math lab, they're going to ask you to write this as inequality. And remember, you are dealing with range. What letter are you going to use with range? Y. Because it's a set of y coordinates. You use your y variable. So in this case, how are you going to write the range as an inequality? Just tell me why. Y is what? All you got to do is tell me, start with y. Y is greater than or equal to a -3. That's all you say. Y is greater than or equal to -3. All right. Now the domain, you're going to move along the x-axis, and think of this right here where I'm at as -1 million. When x is -1 million, do I get a point on the graph?
Yes.
Yes, because remember this thing keeps going, right? So I do. So in terms of this side, do I stop anywhere? I mean, does it stop here, or does it keep on going this way? Yeah. So you're going to go from where? -infinity all the way to +infinity. So the main's -infinity to +infinity. Now, on my math lab, though, now you can't write this as an inequality. So in my math lab, what choice are you going to use? Real numbers. That's what you're going to use in my math lab. Okay, now the one below that one, let's do the range. Now, you see these arrows. So these arrows are pointing down. So I'm going to ask you this: if I put my straw here, does that mean that's where it starts? No, because remember the arrow's going down, so it means that it starts way, way, way down there. It never really stops, right? This arrow's pushing it down, so it's really from where? -infinity all the way, and then tell me where it stops.
5.
At 5. You didn't say stop. So it stops here, right? So what's that y value? What's this y value?
5.
5. So the range is going to be from -infinity, parentheses, -infinity, all the way to what? 5 with a bracket. As an inequality, how are you going to say that? Y is what? Y is what? Less than or equal to 5. Okay? So this time it's less than. Your numbers are 5 is the biggest, right? So all these other y values are smaller than that, so less than. What's the domain? -infinity to positive infinity. So any x value is going to be on that graph. Any real number is going to be on that graph for x. So all real numbers you can say. Okay? All right. Now, on the worksheet, it said, the directions said, when writing the range or domain, you're either going to use an interval or a set notation, right? So when I did this, I used the interval notation so far. So you may say, well, where are you going to use the set notation? Well, that's where we had something like this. All right, I'm going to do on this side. Okay, so that's where we had this. So just go ahead and draw a vertical line like this. And I'm just going to do the vertical line. We did a lot more with this last class period. So if you wasn't here, you really need to look at the videos that go with it. Let's talk about the range. The range is easy for this one. Is this where my graph stops right here or starts? No. The arrow keeps pushing it down. So what's going to be my range from where? Negative infinity to positive infinity. On my math lab, you're going to say real numbers. Now let's talk about the domain. Okay, so is my domain going to start at negative infinity? No. Nope. Because you don't see any arrows pointing this way, do you? So actually, if you look at it, just when I move this straw along the x-axis, where does it start touching the graph?
4.
And then no other place, right? So I really stopped there. So this is the only place. So these x values are all the same. What are all these x values on this line? 4. So it's just a point. So that's set notation. So the domain is going to be the set 4. All right. And that's all you can do. All right. So that's set notation. It's not an interval. You're not going to say an inequality. You're just going to say the domain is just the element 4, because it is. When you look at all these points, remember x equal 4. That's what you're saying, x equal 4. That's that line, by the way. Remember when you graph that line on the worksheet, x equal 4, that's a vertical line? That's what you're saying, x is 4. So try and make those connections. This equation is x equal 4, and that's what you're saying here. All right? Okay, then we also started talking about, actually we talked about this. So if f of x is equal to negative 3x squared minus 5x plus 2, let's say. If f of x equal negative 3x squared minus 5x plus 2. And that's function notation. And remember, f of x means the same thing as what letter? The y. All right? And remember, this is quadratic. Now, the quadratic functions that you had to turn in last class period were easy compared to that. You're going to learn how to do this next semester, how to graph this kind next semester. Because you cannot look at this and tell me what the vertex is. There's no way. So you learn how to do that. There's a vertex formula you're going to use next semester. But it is quadratic. So if you were to graph it, what would the graph be? What would the shape of the graph be?
Vertical.
No.
Curve is
It starts with a P.
parabola.
Parabola. Shape would be a parabola. All right? But you can't tell me the vertex for this one because of that x term. All right. Now, let's go ahead and find f of negative 2. Now, what does that tell me to do? What is it I'm finding? No, you're not. You know what x is. She said I'm finding x. No, you're not. You know what x is. What's x? What's x? Negative 2. You're finding the y value in x is what? negative 2. That's what you're finding. So you want to find f of negative 2. Remember, that's how you read this, f of negative 2. So when you see the variable x, what do you plug in? Negative 2. So I get negative 3 times negative 2 squared minus 5 times negative 2 plus 2. Okay, but then you got to use the order of operations. Remember, please excuse my dear Aunt Sally. So there really aren't any parentheses that you're going to deal with here, because inside this parentheses is just a negative 2. There's no other operations to do inside those parentheses. So the next thing you're going to do is the exponents. Some students make a mistake and say negative 3 times negative 2 is 9, and then, is 6, and then square it, and they get 36. That's not true. You got to do what first? You got to do the exponent first. So what's negative 2 squared? 4. Now what's 4 times negative 3? Negative 12. Okay? And then what's negative 5 times a negative 2?
10.
Positive 10, and then plus 2. When I add these up, what do I get for f of negative 2? 0. That's what you found. So f of negative 2 equals 0. So in the worksheet, you would say something like this. You would say f of negative 2 equals blank, and you could put what in that blank? 0. Now, if you, in terms of an ordered pair, because that's one of the concepts you have to understand, in terms of an ordered pair, meaning if I were to graph this parabola, what point would be on that parabola? What point would be on that parabola?
Negative 2 and 0.
Negative 2, 0. That point, negative 2, 0. So as an ordered pair, you have negative 2 comma 0, because x is negative 2, right? So that goes first. This 0 is your y coordinate. All right, so there are a couple of questions by my slide that talk about ordered pairs, and also on the worksheet. So that was what we talked about last class, at the end of last class period. And this is here. What you're doing is you're evaluating functions. This is evaluating functions. Okay, so evaluating functions. All right, and then let's suppose we had g of x equal negative x squared plus 5x. So g of x equal negative x squared plus 5x. And so let's say we want to find a, and let's say we want to find g of 3. G of 3. So I want to find g of 3. What do I do?
Replace it to
Wherever I see the variable x, I plug in 3. So really I'm finding the y value. All right, now you got to be careful with this one, because what's the only thing being squared here?
the x.
The x. All right, so really you need to say this. You need to say negative, and in parentheses, what do I put inside the parentheses? 3. What am I doing to that? Just that
Square.
3. Squaring it. Okay. Plus 5 times what?
3.
3. All right, order of operations. What now? Okay. Order of operations. Do I say negative 3 times itself, or do I say 3 times itself?
3 times.
3
itself.
times itself. What's 3 times itself?
9.
And so this becomes a what?
Negative 9.
All right, good. Plus what?
15.
And so what is g of 3?
24.
Nope.
Oh, man, 6.
6. All right, so g of 3 equals 6. All right. So what you found was that when x is 3, your y value is 6. Now, on my math lab, there is a question, I think, that does this. So let's just do something like it. Like g of 2/5. G of 2/5. And it's asked you to write your answer as a fraction. So let's just deal with g of 2/5. Let's review some things from when you were a little baby.
That was a long time ago.
Well, I know in my case, like 65
Okay.
years ago.
Mhm. My mouth
Oh, yeah.
from it.
I got a question.
Uh-huh.
Negative 3 squared, not positive 9?
What's being squared? The 2 only is being squared. Oh, not 2, 3. 3 only is being squared. Okay? So in the parentheses, it's not -3. In parentheses, it's 3. But good question.
Is that two what?
Yeah.
2/5. All right, so G of 2/5. Here's what you're going to do. You're going to say, wherever you see the variable x, you're going to plug in 2/5, right? So you're going to get negative, in parentheses, 2/5. And I'm doing what to this 2/5?
Square.
Squaring it. Plus 5 times 2/5, right? Okay, so order of operations. What is 2/5 times itself? 2/5 times 2/5.
4
4
10.
over
2 over
I'm in
5.
25.
25. 5 times 5 is 25, right? You're saying 2/5 times 2/5. So that's 2 times 2 is 4. 5 times 5 is 25. So this becomes a negative 4 over 25, right?
Yeah.
Okay. And over here, I'm going to get, now the 1 and 7, you can reduce if you want to, or you can leave it as 10 over 5 for right now. I'm just going to write 10 over 5 for right now, okay? Now, do you remember how to add fractions with unlike denominators? Find a common denominator. What's a common denominator?
25.
25. All right, your LCD is 25, right? So you're going to write two fractions with that denominator. All right, remember what you said. You said 25 times what is 25? What you do to the, so you multiply the denominator by 1. What you do to the denominator, you do to the numerator. So this becomes a what?
4.
Negative 4. 5 times what is 25? 5. 10 times 5 is 50. So what's your answer? What's a negative 4 25ths plus 50 25ths?
46, negative 46.
Positive 46 over 25. And that's your answer. So G of 2/5 equals 46 divided by 25. Now on your calculator, if you put this in your calculator, so I mean y'all probably got how to add fractions, right? All right. But in your calculator, you just do this. Now you have to now use your calculator. So you just plug it in as you see it. So you're going to say negative, parentheses, 2/5, 2 divided by 5, close the parentheses. What am I doing to it?
Adding it.
No, squaring it, right?
Square.
So square like this.
Where's square?
That okay. And then plus
I see.
5 times 2/5, right? 2 divided by 5. Okay? Just like that. Press equal, and that's what I get. I get 1.84. Okay? But you want to leave it as a fraction. You want to leave it as a fraction. So here's how you can convert this back to a fraction. You see, right above that PRB right here, in blue, it says F to D. F to D, D to F. So fraction to decimal, decimal to fraction. To get to it, though, you got to press the second button. So you press second, PRB,
Oh, I got a syntax error.
and then press equal, and you get this. Now, what this did was it converted that decimal to what kind of number? What kind of number is this?
That would be,
A mixed number. A mixed number.
what is that?
So that's 1. So this is 1 and 21 over 25. That's what that says. Huh?
You got to do it like that?
No, you could do it like this. I'm just showing you how you can check it on the calculator. You need to be able to use your calculator to check things. Okay? So this right here reads 1 and 21 over 25. Now, do you remember in a couple of courses ago how to convert a mixed number to an improper fraction?
Multiply the
You multiply 25 times 21. I'm sorry, 25 times 1, which is what?
25.
Plus a 21, which is 46.
Yeah, that's how I do it.
Okay? All right. Okay, so if you need more work with your calculator, just see me after class, okay? All right. Okay, so let's continue on. So this was a quick review. Okay, so let's look at this. All right, so this function right here, f of x equals 3x minus 2, is that a linear function, a quadratic function, absolute value? What is it? It's linear, right? And here's the graph right here. Here's the graph. So basically, you would use a t-table and you would graph this. You do that on worksheet number 1. But if I ask you to tell me what f of, let's say, 2 is, what f of 2 is, you don't have to go back to here if you already know what the graph is, right? So this says what, remember f of 2 means what is the y value when x is what? 2. Well, when x is 2, what's my y value? 4. So this is 4. You agree from the graph you got 4, right? And you can check it. What's 3 times 2?
6.
And what's 6 minus 2? 4. All right. So I brought this up because I'm about to give you a handout. Okay. All right, I'm about to give you a handout in which we're going to talk about this. So take one, pass the rest back. The extra ones, I need them because for the next class. So don't keep 5 of them for yourself. Okay. So quickly get one. All right, so again, we're still talking about functions. All right, number 1, it says use the graph to answer the following. All right, so this graph here. And you're asked, what is f of negative 2, right? So to find f of negative 2, remember what that means. That means what is the y value when x is what? Negative 2. We've discussed this before. When there are no numbers listed along the x-axis or y-axis, assume that each one represents 1 unit. So if x is negative 2, that's this right here, right? So look at the point that corresponds to it. That's this point. Yes or no? What's that y value?
2.
2. Very good. So this right here is negative 2, 2. So when x is negative 2, what's the y value? 2. So you put 2 in the blank.
Negative 2.
Okay? The next one. Find the values of x for which f of x is 2. All right, let's talk about that idea. What does f of x mean?
Why?
Why? So I'm asking this. I'm asking what values of x, what is x going to be if y is 2? That's what I'm asking. Hold on. What is the value of x when y is 2? So look at your graph. Look at that graph and look specifically for the point or points where y is 2.
Why is not 2?
Do you see where that's located? So it helps though. Remember when y is 2, you see on the y-axis, this is 2 right here, right? You all agree this is 2 on the y-axis?
Yes.
Okay, the point that corresponds to that is this one and this one. Do y'all agree that this point here, my y value is 2?
Yes.
All you have to do is tell me what the x value is. What's that x value? 1, 2, 3, 4. You're right. So what are my x values?
Negative 2 and 4.
Negative 2 and 4. Very good. So all you have to do is just locate the points in which your y value is 2. So it helps to go along the y-axis to find that y value and then the point that corresponds to it.
So when we find the number of x's, only calculate a certain number of points over, or?
I don't understand what you mean. What do you mean? Tell me what you're talking about.
Like right here.
Okay. All right, C. What are the x-intercepts? You've had that before. X-intercepts are where the graph does what? Cross the x-axis, right? So do you see where the graph crosses the x-axis? How many places?
Two.
Twice. So -1, and what's the other? 3. I did not say rise in ordered pair, so it is okay to say what? -1 in one blank and 3 in the other. Okay? All right, let's do D. F of 0. What are you asked to find when it says find f of 0? What is it you're finding? The what?
Is it the origin?
No, I'm not asking that. I'm saying when you're told to find f of 0, what is it that you're finding? The y value. You're finding the y value when x is what? 0. So locate when x is 0. So where's x 0? No. Where on this v is x 0? No, that's not 0 right here.
-2, my bad. -2.
On the y-axis. Do y'all remember when we
On the
graphed lines?
y-axis
Oh,
is
yeah. It's -3.
1, 2, 3, 4.
Stop. Do you remember when you graphed lines, worksheet number 3, I asked you to graph using intercepts? When we found the y-intercept, we let x be what?
0.
0. So when x is 0, you're finding the y-intercept.
Is it not -2?
It is -2. But most of you are saying all kinds of stuff. And so I had to tell you, I had to get you to stop. So here, you're going to say f of 0 is what? -2, because you can see this. See this point right here? If you label it, in that 0, -2. So when x is 0, your y value is -2. Notice there are a couple of you, at least a couple of you, there are more that probably thought it, that said that f of 0 was 4. That's not true. This point here, what are the when you label that point, what are the coordinates?
4, 0.
4, 0, not 0, 4. That's 4, 0. Okay, so as we go through this, notice your misconceptions and try and fix those. Because some of you are still having issues with x and y intercepts based on what we're doing right here, okay? What is the y-intercept? The y-intercept is where the graph does what? Crosses the y-axis. What is it? -2. We found it right here. -2. All right. Complete the ordered pair. Fill in the blank. So here I'm asked to, you're given what here? X. And what's X? 6. And you asked to find what?
The Y.
Y. Okay, good. So an X is 6. So this is 4 right here, right? 5, 6. And the point that corresponds to it, so this is 6 for X. What's that Y value? 4? No, 6?
6. You at the wrong point.
I'm at the wrong point.
Yeah, it's the last line.
4, 5. Oh, this is 1,
That's
2.
three.
Oh, I'm sorry. That was 3. Excuse me. So 3, 4, 5, 6. So right here. So 6 right here, right? So that's 6, comma 6. All right. Thank you. So 6, 6. All right. Let's get the next one. F of -3. What is it you're finding? The y value. So you're asked what when x is -3, what's the y value? So you look at your graph. X is -3.
No, +4.
Wait, hold on, guys. This right here is x -3, right?
Yeah.
All right. The point that corresponds to it is down here,
-4.
-4. That's -4 because if you label the point, and for some of these, it might be a good idea to label that point. That is -3, comma what? 4. -4. Excuse me. -4. So when x is -3, what's your y value? -4. Okay. What about alpha 4? Again, that means when x is 4, what is the y value? So on the x-axis, you locate 4. Well, 4 is here. Locate the point that corresponds to it, and that is
Two.
here. So that's 4 comma 2. So the answer is 2. Same thing we did a while ago in the previous problem. What values of x, find the values of x for which y is what? Negative 2. The way I would do that is I would go along the y-axis and find negative 2.
Alright.
So negative 2 is right here that I'm pointing to, right? Locate the points that corresponds to it. There are how many of them?
Two.
Very good. There's this one,
That one.
and there's this one. So if I label that point, that is,
Negative
Seven.
two.
no, be careful. Right, let's do this one first. Let's do this one first. That is 5, 6, 7, negative 2, is that correct?
Yes.
Okay. And this one is
Negative 2, negative 2.
negative 2, negative 2, yes. Where'd you get negative 3 from?
I didn't say 3. I said something. I said
Okay. All right, so what are the x values?
Negative 2 and
Negative
7.
2 and 7.
Yep, very good. All right, good job.
Wait. I lost you. So
Locate the points and label the points. So that's this point negative 2, and this point 7, negative 2. So you're told the y value is negative 2. What's the x? So the x is negative 2 and the x is 7. What are the x-intercepts?
Negative 2 and 7.
Nope, not negative 2. Negative 1 and what?
6.
6. It crosses the graph here, right? I mean, it crosses the x-axis here. Negative 1
Oh. You're right.
and 6. That's right across the x-axis.
Yes.
What is the y-intercept?
2 and
2.
5.
No, it's only one place, right here. So it's 2 only. All right, let's look at this one. What do you think f of negative 50 is?
Yeah, negative 4.
All right.
Because that's where it stopped at.
Well, it doesn't stop there. It keeps on going, though, right? See this arrow right here? So I did that because I wanted to give you an x value that was beyond what you saw. But notice this part of the graph keeps on going horizontally, right? So that means that all these y values right here is going to be what?
Negative 4.
Negative 4. So when x is negative 50, what's going to be that y value?
Negative 4.
Negative 4. Okay.
So what he's saying is negative 50. is
How many
on-
values of x
on-
does f of x equal 2? Okay, very good. All right, so listen carefully to this. You're told that y is what here? Y is what? 2. Look at all these points where y is what? 2. We had a discussion last class period about that. You're not just looking at whole numbers, you're looking at any real number. How many real numbers are on this segment right here? An infinite number. So the question is, how many y values of x does f of x equal 2? You're going to say an infinite number.
Can we write the infinity sign?
No. Can I write the infinity sign? You got to say an infinite number. Don't say all real numbers either. Yeah, because it's not all real numbers. It's only those numbers that are located where? Within that part right here. So just say an infinite number, because that's all I wanted you to tell me. How many are there? There's an infinite number. Okay? Does f of h equal 2, yes or no?
No.
No. In fact, let's see. So that means that when x is 8, right? When x is 8, very good. My y value is supposed to be negative 4. So the answer is no. So let's actually say what it is. That's because f of h should equal what? Negative 4. Does f of 6 equal 0? Yes or no?
Yes.
Yes, it does. Because remember, that says what's the x value? I'm sorry, what's the y value when x is what?
The x
6.
value
So when x is 6, that's this point right here, right? What's that y value? 0. So it's yes. All right. Okay? It's not that difficult. Most of this is not that difficult. There are some you have to go back and kind of look at again. All right? But for the most part, it's very straightforward.
It's
Okay? All right. So let me give you the worksheet that deals with this one.